Yeah, hi, welcome. So in this video, we are going to discuss about top 20 Java stream operations. So the first one here is the filter one. Okay, so we have a stream of elements and we want to filter those elements based on a given condition. So we use a filter method within which we mention what is the predicate for it. So here we just want the list of only even numbers. So that is what we are going to mention here. So based on that, we are going to get only the input. We are going to get only the even numbers. So it may happen that the number of elements in the stream and what is filtered might get changed. Okay, so it has to keep only those elements that matches the specific condition. So it's very easy to understand. So the next one here is the map. Okay, in map method, what really happens is we transform each element in the stream. For example, here we have a list of a list of strings. Okay, and we just want to convert them into an uppercase. So here we can use a map method wherein we specify what transformation we need to provide, and this transformation is applied to each element of the stream. So here the number of input parameters or the number of elements in the stream is equal to what is there in the output. So the third operation here is the flat map. It actually flattens the nested structure here. Okay, let's say you have a stream of elements and you want to flatten them. For example, here we have the list of numbers and we just want a list of integers, not the nested list herein. So we can use a flat map. Within the flat map, we can specify a inner list. So what happens is for each inner list, we convert it into a stream, and the flat map is going to join all the inner streams into one. Okay, so here we have 1, 2, 3, 4 into different lists, and the output we get this way like 1, 2, 3, and 4, which is flattened. Operation is very simple. It is going to remove the duplicates from the stream. So we have a stream of numbers and it contains the duplicate here, and after streaming we apply a distinct method here and we just collect them into a list. Okay, so here we get 1, 2, 3. So very important for getting the unique elements in the stream. So next is a sorted. It is going to sort the elements. Okay, in the ascending order by default. So sorted arranges the elements in the natural order. Okay, the numbers are in the ascending order and the strings are in the alphabetical order. So here we have the numbers here and we apply a sorted method here, and we can, after sorting, we can collect those elements in a list. Or you can use a, if you want, in a descending manner you can just mention argument in the sorted like a comparator or reverse sorter. It's going to give the sorting in the reverse order, that is in the descending order. Okay, limit means it takes the first n elements. Okay, if you're mentioning that like a top n elements, okay, let's say you have a stream of elements and you just want the first three of them, so you can just mention those numbers here in the limit 3 and then collect them in a list. So you get only three elements. Let's say there's a use case wherein we just want the top first element or the top second element, so that way we can use a limit to get those elements. Okay, and there's one more use case wherein we want to skip the first two elements, and you want to see the stream only after a certain element. Let's say you want to first skip the first one and take the next one, or skip the next skip two elements and then go further and again for the next elements. So here in this case we are skipping by 2. That means it's going to start from 3, 4, and 5. It's going to give the output here as 3, 4, 5, and you want to collect them in a list. So the next one here is a peek method wherein we are using it to debug or to inspect the elements. For example, here we have the list of numbers here. We want to see which number is getting processed here. It doesn't do any transformations per se. It is just used to inspect the elements and see which element is getting processed. So it doesn't modify anything. It's just used for debugging purpose. So here if you can see here we have a stream of numbers here and we are printing that out. Okay, and we just find out which element is getting processed, and at the end we are just collecting those elements back. So next is a count. It is going to just count the number of elements in the stream. Okay, so we have here the 5 elements. It's very simple. It is just going to give the count of the elements. which are present in the stream. Next one is anyMatch. Okay, so anyMatch means it is going to check if any element, at least one element, satisfies the condition. So here we have given the condition the number should be greater than 2. So we have like 3, 4, and 5 which are greater than 2. So it is going to print out the true value. It is going to check only one of them for the condition. It did not be all of them, just one of them. And if at least one of them satisfy the condition as mentioned here, it is going to print the true. Similarly, so there is something called an allMatch. So earlier we saw about anyMatch. So here the condition should be satisfied for all the elements in the list. Here we are checking if the number is greater than 0. So all the numbers are greater than 0. So it's going to print true here. If at least even if one of them doesn't satisfy the condition, it is going to give the false. So ideally it is used to check the condition for all the elements here. Okay, there is something called as noneMatch. So check if no elements should match. Okay, here also it's a little reverse of allMatch, wherein we just checked, whatever conditions which you are specifying here, none of the elements should match the condition. You're mentioning a number is less than 0, so none of them are matching that condition. Here, if here it was something like -10 or -1, which is matching the condition, at least one of them, then it will give false. Okay, so here all of them are not matching the condition. So hence it is the value is true. Okay, 13 is the find first. Here we get the first element. Let's say you have a list and you just want only the first element. If none of them are there, then it is going to give us a null. So here, okay, it gives the output 1 because here 1 is the first element here. findAny. So basically, this is going to it's going to give any, by default, it's going to give the first one element because the first element it is going to encounter, it's going to give the output as 1. It is used mainly in parallel streams but works in normal streams also. Okay, reduce. Okay, as the name suggests, it combines the result into one result. So basically, reduce operations are like summing of all the stream elements, or getting the product of it, or finding which one of them is the minimum or the max of it. So here we are trying to do a summation. So we just mention the initial value as 0, and we just specify what operations needs to be done here. Okay, and based on that, it's going to give you the output here. Basically, it's just used to combine all the elements and give one result. So next here is a collect to list, where we are converting it into a list. Okay, so we have the list of elements. For example, we are filtering those elements based on given predicate that like we want only the even numbers here, and we are collecting them into a list. So this we are using very frequently, okay, to collect them into a list. Okay, and it's going to print in this manner. Or similar as we have something called as a toSet. Okay, now toSet is going to remove all the duplicates. Okay, toList is not going to remove any duplicates. It is just going to give the input as it is. But if you want to remove the duplicates per se, here we can just, for example, here we have duplicates of 1 and 2. So here we are going to get the output as 1, 2, 3, 4, and 5. It is just going to collect it in a set, not a list. 18th one is a grouping by. Okay, so what really happens here is let's say we want to partition the elements which are present in the stream by a given criteria. Okay, for example, here the criteria is the first element of the string. Let's say we want to partition by A, partition by B, and based on that we get an output here. So the key here is the character by which we are partitioning and the elements which are satisfying that criteria. So here, let's say we want to partition by A. So the elements which are satisfying the criteria are apple and ant. Here we want to partition by B. So the elements which are satisfying the criteria are ball and bat. So here it returns a map, okay, like character and the list of which is satisfying the criteria. So this is how it works here. Basically useful for categorizing the data. And here we use the example of first letter of the string. 19th is joining the strings. So we use something called as collectors.joining, and we specify by what it has to be joined. and we can just collect that in a string. So the last operation is the for each method. So for each method performs an action on each element here. So here we are just printing out each and every element here. So take each element and perform certain action on it. It's a terminal operation. Okay. So that's it from my side. I hope this tutorial was very helpful to you. Thank you very much.